In this example, we will try to find out the expansion of sine inverse of x. Let f of x equal to sine inverse of x, which is equal to y. Let us differentiate with respect to x. So derivative of y is nothing but dy dx, and derivative of sine inverse of x is 1 upon root over 1 minus x square. And we know that 1 plus x to the power n by using the binomial expansion, which is equal to 1 plus nx plus n into n minus 1 upon 2 factorial x square plus n into n minus 1 n minus 2 upon 3 factorial x cube plus n into n minus 1 n minus 2 n minus 3 upon 4 factorial into x to the power 4 and so on. So these are the binomial expansion of 1 plus x to the power n. So can we write down 1 plus 1 upon root of 1 minus x square can be written as 1 minus x square whole to the power minus 1 by 2. So here clearly the value of x is minus x square and the value of n is minus 1 by 2. So let us put over here 1, the value of n is minus 1 by 2, the value of x is minus x square plus 1 upon 2 factorial. This is 1 upon 2 factorial. What is the value of n? N is nothing but 1 by 2. So 1 upon 2 factorial we have taken outside. Then the value of n is 1 by minus 1 by 2. The value of this n is again minus 1 by 2 minus 1 minus what is the value of x? The value of x is minus x square whole to the power 2. Whole to the power 2. Here the power is 1, then 2, then again next term it will come 3. Plus 1 upon 3 factorial n into n minus 1 minus 1 by 2 minus 1 into n minus 2 minus 1 by 2 minus 2. And what is the value of x? X is what? It is nothing but minus x square and whole to the power 3. If we simplify this expression, we are able to get the first term is 1. This is very clear. In the second term, minus 1 by 2 into minus x square, it is nothing but 1 by 2 x square. Then 1 upon root 2 factorial is 1 by 2 minus 1 by 2 minus 3 by 2. Just look here, 1 by 2, 1 by 2, 3 by 2. So this minus and this minus will become plus. So ultimately we are getting 1 by 2 factorial means 1 by 2 into 1 by 2 into 3 by 2 into 3 by 2. Then the next term will be, what about the third term? This term, fourth term, sorry, third, 1 is over, 2 is over, 3 is over. Now fourth term, 1 upon 3 factorial, which is nothing but 1 by 6. Then minus 1 by 2, 1 minus 2 minus 3 minus 3 minus and x to the power minus x square whole to the power 3. So 4 minus. So if we multiply 4 negative number are minus x into minus x into minus x into minus x into minus x, any negative number up to 4 terms, we get the positive value. So now it is written positive. Okay, the next thing is 1 upon 3 factorial is 1 by 6 minus 1 by 2. We have already taken all these value will become positive, right? Yes. So 1 by 2, this is 3 by 2, this is 5 by 2. Okay, and x square whole to the power 3 is x to the power 6. Now let me go ahead and simplify it. 1 plus x square upon 2, then 1 by 2, 1 by 2, 3 by 2 into x to the power 4 plus 1 by 2, 1 by 2, 1 by 2, 5 by 2 x to the power 6. How we are getting this one? So now we have to just cancel out this thing. This is as it is, nothing is changed. And here uh, this will be written as, so 3 1 ja 3, 3 2 ja 6, 2 1 ja we are not able to cancel it. So 5 upon 32 x to the power 6. So now let us integrate it. With respect to x, we have integration of dy when y tending to 0 to y, which is equal to integration of 1 plus 1 upon 2x square plus 1 by 2 into 1 by 2 into 3 by 2 whole to the power x to the power 4 plus 1 by 2 into 1 by 2 into 1 by 2 into 5 by 2 x to the power 6 upon x to the power 6 and so on. Now, if we use the integration, we know that what is the integration of 1 is nothing but x. Then integration of x square is x cubed by 3. So 1 by 2 is the initial part. This 1 by 2 into 1 by 3 x cubed by 3. Then 1 by 2, 1 by 2, 3 by 2. So this 3 term is similar, or we can, it is taken from previous part. And x to the power, what is the derivative of x to the power 4? It is nothing but x to the power 5 upon 5 plus here 1 by 2, 1 by 2, 1 by 2, 5 by 2, x to the power 7. So these are the calculation of y equal to sine inverse of x. Let me write down the correct answer. So expansion of sine inverse of x is nothing but x plus x cube upon 6 plus 1 by 4 into 1 by 4 into 3 by 2 into x to the power 5 upon 5. So if we simplify it, it will give us x to the power 3 x to the power 5 upon 40. And similarly, if we simplify this one, we are able to get 5x to the power 7 upon 112. So this is the expansion of sine inverse of x. Let me write down what is the expansion of cos inverse of x. So it is very simple. We can derive the series expansion of cos inverse x by using this formula, f of x equal to y, which is cos inverse of x. We want to find out its expansion. We know that cos inverse of x plus sine inverse of x equal to pi by 2. So what is the value of cos inverse x? It is nothing but pi by 2 minus sine inverse of x. But we know that the series expansion of sine inverse of x is equal to 1 plus 1 by 2 into x cube upon 3 plus 1 by 2 into 3 by 2 into 5x to the power 5 upon 5 plus 1 by 2 into 3 by 2 into 5 by 2 up to x to the power 7 upon 7. So this is the expansion of sine inverse of x. And if we substitute this value over here, we are able to get the cosine inverse of x uh, using the formula of sine inverse of x. So now what is going to expansion of cosine inverse of x? It is nothing but pi by 2 minus 1 plus 1 by 2 into x cube upon 3 plus 1 upon 2 into 3 by 2 into x to the power 5 upon 5 plus 1 by 2 into 3 by 2 into 5 by 2 into x to the power 7 upon 7 and so on. Hence, this is the series expansion of cosine function. Thank you.